Let me give you at least a quick overview about the organization. What is the most important thing is we are not really a national laboratory with EFRIP. We are run under what is called a cooperative agreement, which has a lot of advantages and flexibilities as compared to how a national laboratory functions. But what it means in concrete terms, the person ultimately responsible for the EFRIP project is the president. Of course, the president is not going to build it, so the president is going to delegate authority to the lab director, who is delegating the authority to the person who's really going to do the job, okay, which is Thomas Glasmacher as the project manager. And he's in charge on delivering the project on schedule and on budget, okay. The laboratory's office has sort of two functions, okay. It runs a number of high-level committees so that the project goes in the direction, and also is going to be responsible for user relations. Actually, the point person, that's the most important thing for you all. When you want to get involved in EFRIP, is you have to talk to the chief scientist, Brad Schell. He owns the user relationship and has to make sure that everything comes together. He will advise the laboratory director what are the right things, and the laboratory director has promised he's going to listen very carefully to that advice. And I can assure you that I am going to listen very carefully to all the advice we're getting, because at the end, science is what matters. It's the only thing which is important. And then I won't go into the detail. You have the typical advisory committees, and you also have typically the management structure, which is aligned with the work breakdown structure of the project. But I just wanted to give you a little head up. Now, how does it look like? Okay, so we've tossed around a lot with the ideas how we would build this facility. At the end, the conceptual layout and the scope of the facility will be like this. The stuff in light green is what you see basically right now. This is the new office tower, which is we're just moving into. This area here is the area for re-accelerated beams. And then these gray buildings, this is still the old conceptual design for the second office tower we want to build, so that hopefully will get replaced by something more intelligent. And then this is the area for the higher energy re-accelerated beams, which still needs to be built. And then you have this stuff where you produce the rare isotope beams. Okay, so this is here where the fragment separator is connecting in with the existing facility, and then down here you have a tunnel, the production area, and the most important part here is of course the deep tunnel, which is housing the re-accelerator. Now, we went through a lot of iterations, and I don't want to bore you too much with details, but what is important is any team which is worth its salt will think not only meeting the specifications of the project, but also make things in such a way that if there are new scientific opportunities, that you have not painted yourself into a corner, that there are additional opportunities you can take advantage of. And so the MSU proposal had a number of easy to implement upgrade options. For example, this tunnel, yeah, you could shorten it discretely by yards. Okay, let me kill this here. By the yard, but what is very important is that you provide yourself sufficient length that you can upgrade the energy. Well, yeah, it was 400 MeV. There were a lot of good scientific reasons why it was a 400 MeV accelerator. Once you build a tunnel, you don't want to build a tunnel and then add on to the tunnel. You build the tunnel once and you're done with. Okay, so like at Jefferson Lab, there was space in the tunnel to provide for a future energy upgrade. And certainly our concept right now is to provide sufficient space for an energy upgrade, up to full RIA specifications. And that has a lot of advantages for a number of beams, especially those which are produced by in-flight fission. So that's an important issue. We're building a larger switch yard and target area, sufficient that we could either go build a second fragment separator to have true multi-user operation, or we could also add a couple of ISO target stations. Okay, so that is that you can run ISO or in-flight production capability. So that's another very important addition. So depending on what the science dictates, sometime down in the future, we could sort of decide one way or the other and make some good selections, and you haven't precluded science-driven upgrades with the facility layout. So that is something which I think is very important, that this is in the design. Now, if you look at, take a bird's eye photograph, and this is satellite photograph, or it's not a satellite, it's from an airplane, but nevertheless, this photograph here, it's sort of taken some time ago before we had this office wing, so it's more than a year old. So we just painted this in. This is the new office wing, and this is the low energy experimental area. But then you see how all the other components, the second office tower, which will look differently, as I mentioned. Then this is the target area, and then you have this deep tunnel. The light shading is basically what will be covered by Earth again. Okay, so right now we have one tunnel design which looks like this, but we're looking at other options right now. Okay, there may be, you have to sort of balance the pros and cons with a tunnel which could be folded, which would be a more natural way to build a second injector in case you want to have dual beam operation. So there are other things which we're going through and evaluating for the next half year until at some stage the baseline is getting frozen. So I just wanted to let you, but it fits very nicely onto this relatively complex thing. The main reason is that MSU gave us permission to build a deep trench, put all the equipment in, and then cover it up again. Okay, so there will be a big scar on the Earth, and at the end it looks better than new, and nobody will see it from the surface. Very important for the user community is that as we're evolving the facility, there's sort of two cut points. There's one here. All the equipment will stay. So we don't want to build stuff and tear it down again. I mean, things will always change, but the current plan is whatever we do should be thought through with the end goal that it's going to go into FRIP operations. We don't want to build something, tear it down, because we said, oops, this is only good for the next 2 years. So this area will be completely commissioned independently of the FRIP driver coming online. But we can commission it with a coupled beams from the coupled cyclotron facility and the A1900 fragment separator feeding into the experimental area. Now, when FRIP the driver LINAC is built, so this is here the tunnel, which is going to go somehow like this. We can commission the driver accelerator while we're running a research program with the coupled cyclotron facilities. At some stage you said, it's good enough, let's go for the real thing. What you will do, you will disconnect out here, mothball the cyclotrons and just let them sit there, and then tear down through the wall here, and then rearrange the magnets to connect to the driver accelerator. When we talked about this, my internal goal was we should really do this, be able to do this. If funding and everything else works out well within half a year. I think it's doable running 2 shifts, which means basically the research program for everybody who's going to train graduate students won't take a hit at all. It's like a long maintenance period. Okay, and then we're starting up the research program. Certainly, if you plan in contingencies, it'll be much shorter than the coupled cyclotron shutdown, if the funding flows right. That means, of course, the agencies need to talk and be all on board with the same funding scheme. And I think the way it's teeing itself up, I believe this is going to happen.